Okay, well, welcome to the practical part of this lab, experiment number 4 on ammeters and voltmeters. And let me just say that I'm glad that you're excited to learn about ammeters and voltmeters. I think that if you really understand the inner workings of these devices, it will help you to understand how to work with resistors and voltage supplies in parallel and in series. So first of all, just the things that you'll need some wires. You'll need 4 connecting wires. These are the banana plug type. It doesn't matter about the colors, but here I have 2 red and 2 black. You'll also need a 1 amp ammeter. So this is our ammeter. Remember, you can look in the back and go ahead and look and see. You can see that wire. That is the shunt resistor. You'll need a voltmeter. Right here, it measures 10 volts. They'll all look like this. Yours might be gray, but it's the same. You'll need a multimeter. We've used this for the capacitors lab, but this is a different device. It measures voltage, resistance, and current. So you'll have a voltmeter like this. I'll show you more about that in a second. You'll need a decade resistance box. This is very important on this decade resistance box. It has a series of dials that have times 1. So if you wanted 2 ohms, you would just move the times 1 to 2. Now you're not going to use this first dial, so just set it to 0. In fact, on a lot of them they don't work because students have burnt them out. But all the others should work. Mostly you'll be using the ones on the top row. So for example, if I wanted 200,000 ohms, I would move this dial, which is times 100K, to 2. That would be 200,000. And then if I wanted 200 and say 30,000, then I would move this dial to 3. This is 200, 2 times 100K plus 3 plus 30,000, 3 times 10K. So that would be 230,000 ohms. This is a decade resistance box. Play around with it, and if you need help, ask your instructor on how to use that. But important thing, not using the times 1. Not using the times 1 at all. I said most of them it doesn't work anyway. You'll need your resistor boards. Have it right here. You'll also need a 1 ohm resistor. That's in your envelope of resistors that you'll have at your table. And you'll need your shunt. This is just a piece of wire. I actually took this piece of wire out of our house. So this is the kind of wire, it's just copper wire that you have in your house electrical system. You'll need a vernier caliper. You'll use this to measure the dimensions of the wire. And you also need a ruler to measure the length of that wire. Okay, so those are all the things that you'll need. The very first part is measuring the resistance of a voltmeter. So you're going to take your decade resistance box, make sure that it's all set to 0. Every dial is set to 0. And you're going to place it in series with your voltmeter and your power supply. So take your decade resistance box, you're going to connect it to your voltmeter, and then also to your power supply. Remember, red to red, black to black for your voltmeter. So I have the side that's closest to the red connected to the red side, and then my power supply hooks up to my decade resistance box. So I like to sort of move these things out, and then you can see how this circuit now is in series. Watch, I can trace it out. I start with the red, I go through the red on my voltmeter, then that goes over to my decade resistance box, and then back to the power supply. So I have the voltmeter set up in series with the decade resistance box. Initially, you're going to have this set to 0 ohms, and then you'll turn on your power supply so that this reads full swing voltage. Now what we want it to do is calculate then the current that is required to make that have full swing voltage. And you want to have it so that you're going to increase the decade resistance box, the resistance on the decade resistance box, so that this voltmeter will read half of its original value. And then think about how are the resistors in the decade resistance box and the voltmeter, how are those two related? Once you have the resistance of the voltmeter, you should be able to figure that out from that information. Once you have the resistance of your voltmeter, then you can calculate what is the full swing current, the current required to make this thing go to full swing. So that's your IFS, your full swing current. In part 2, you're going to find the multiply resistor that will increase your voltmeters by a factor of 10. So the way you're going to do that, you're going to have this same setup. First, you want to calculate what RL should be. Look back in the theory section. You can calculate what RL will be in order to give us a VFS prime here of 100. Now, what that means is that if this, for example, reads 10 volts, then really the voltage in our circuit is 100 volts. I want 100 times multiplication. So calculate what RL should be, and then think about what I do in order to make this have a 10-fold multiplication. That is, if I have 10 volts coming off of my power supply, then what must this resist, or what will this read if I actually have a 10-fold multiplication? All right, think about that. If I know that my actual voltage is 10 volts, what is this voltage going to be? What is this voltmeter going to read if I have a 10-fold multiplication? Okay? And you can change your decade resistance box in order to set that voltage so that it has this 10-fold multiplication. In part 3, you're going to measure the resistance of your ammeter. What you're going to do there is set up your ammeter in series with a resistor. Oh, you might need some different wires. I don't think these banana plugs work. Yeah, I think I can sort of. Well, you'll have some different wires that will connect onto these boards. Now remember, on these boards, you connect your wires here. So I connect my wires here and here, and I'm going to set my ammeter up in series with my 1 ohm resistor. Okay? So I have my ammeter set up in series with my 1 ohm resistor. You're going to adjust the power supply so that I read a full scale current. And then you're going to use your multimeter in order to read the voltage of that ammeter with a full scale current. So use my multimeter. I'm going to set it to 2 volts because it's going to be a relatively small voltage. And I'll set this in parallel with the ammeter. And I can then measure what is the voltage across this ammeter when it reads full swing current of 1 amp. Now when it reads 1 amp, what is the voltage? If you have the voltage, which you measure from this, and you know that the current is 1 amp across this ammeter, then you can figure out what is the resistance of that ammeter. So you calculate that ammeter resistance. Now, the next thing you're going to do is measure the resistance of an external shunt resistor. So this is a little tricky. You're going to use the same setup. You're going to have this set at full swing. And let's see, you're actually going to have some different wires that will connect here. Okay, your instructor will give you those wires where you unscrew these and connect the wires here. So I'll just sort of set them right here. And you imagine that they are connected there. Then you're going to take your shunt resistor and you're going to place it inside the terminals. So this shunt resistor is now connected in parallel with the ammeter. You might have to sort of push it in there and then either pull up or push down in order to get the shunt resistor to make full contact with the terminals. So pull up or push down. You'll get the hang of it, and you'll actually be able to see because this current will decrease as you make full contact. So find the position of your shunt resistor so that you get the minimum current on the ammeter. So remember, the shunt resistor is multiplying the range of your ammeter. I know that my actual current is 1 amp, but when I put in the shunt resistor, I should see a smaller current. So connect your shunt to the terminals of the ammeter. Note what happens to the current reading on the ammeter, and then talk about how is the path of the current changed when you add the shunt, right? The current is now going to split up in some way. You're also going to measure and record the dimensions of your shunt. Oh, by the way, so when you do this, measure what is that new lower current. Measure the dimensions, measure the diameter of the wire, measure the length of the wire with a ruler. That will be your lowercase r, and your radius, or your diameter, you'll divide that by 2 to get the radius, and your length. Calculate the resistance of the shunt wire using our equation R is equal to the resistivity times L over A. Remember, the area of a circle is pi r squared. To find the cross-sectional area, you have the diameter and then pi times the radius squared. You can also calculate the shunt resistor. I'll refer you back to the theory section. You can look back in that. If I know what is the decreased current here, what is the value of the resistor here? What is that shunt resistor? That's in part 3 of part 4, or step 3 of part 4. And then you calculate the resistance of the wire given the dimensions. Then you calculate the percent difference. So you're doing two things. You're measuring the resistance of this wire based on its dimensions, and then you're also measuring the resistance of this wire based on what it does to the ammeter as a shunt resistor when I place it in here. By how much does it cause that current to decrease? Okay, so that's it. It's the ideas in this lab are complex. So spend some time really struggling through some of these ideas. And as I said, that will really help you in the class to understand resistors in series and parallel and how voltages and currents are distributed across those electronic devices.